Hey guys, welcome to my channel. Today we are going to discuss how to calculate the reaction forces for a simply supported beam. Here we have a beam of AB equal to 400 mm length and force of 100 kN is acting at a point C. Before calculating the reaction forces, we must draw a free body diagram. Here we have a beam AB and a 100 kN force of 100 kN is acting at point C. We are going to have a reaction process where the beam is supported. At point A is beam supported as well as point B where the beam is supported, because we have a reaction force upwards. Also we have a reaction force upwards. I am going to call it as a RA, reaction force at point A, and RB is the reaction force at point B. This distance is 200 mm and this distance is 200 mm. This is a free body diagram where all the supports are removed. Only forces and the beam are taken into calculation. We take upward forces as positive and downward forces as negative. Sum of all the forces should be equal to 0. Therefore RA is the force which acting upwards. We take it as positive RA, and 100 kN is the force acting downward. We take it as 100 kN. We take it as negative. And RB is the force acting upwards. We take it as RB, which is equal to the 0. Sum of all the forces is equal to 0. We take unknown things to the left side and 100 kN to the right side, and we call this as a equation 1. Let take momentum at point A. Momentum at point should be equal to the 0. We know momentum is equal to the force into perpendicular distance. Let take clockwise momentum as positive and anti-clockwise or counterclockwise as negative. Therefore momentum at A equal to 0, which is equal to, we have a force RA. We don't have to take this force because we are calculating the momentum for point A. The forces which act to the point for which we are calculating should be neglected. Therefore we are neglecting the point force RA and taking only 100 kN and RB. Therefore RA for 100 kN which causing clockwise momentum. Therefore we take it as a 100 into 10 to the 3 positive, and its perpendicular distance of RB. Distance of this force is from point A is 200 mm. Multiply with this 200 mm, the force RB which cause the counterclockwise momentum about point A, cause the counterclockwise momentum about point A. Therefore we take RB as negative, which causes the counterclockwise momentum. And the perpendicular distance of RB from point A is 200 plus 200 equal to 400. We take this RB into 400 to the left side. 400 RB equal to left side, and 100 into 10 raised to 3 into 200 to the right side. We calculate this. 100 into 10 raised to 3 into 200, which is equal to the 20 into 10 raised to 6, and RB equal to 20 into 10 raised to 6 divided by 400. This is in the Newton mm, and the 400 mm is the distance. 400 is the distance, which unit is mm. This mm got cancelled. This 100 into 10 raised to 3 in Newton, and into this 200 is in mm. Therefore, we take it as a Newton mm. We got RB as 50,000 Newton. We got RB as 50,000 Newton, which is equal to the RB into 50 into 10 raised to 3 Newton, also equal to the 50 kilonewton. Let's call this equation as 2. Kilonewton. Ra equal to 50 kilonewton. Kilonewton. Ra equal to 50 kilonewton. We got Ra as 50 kilonewton and got Rb as 50 kilonewton. Ra and Rb, these are the reaction forces which acting on the beam.